So this topic is about aspirin and penicillin. We'll start with aspirin. So the therapeutic properties of the willow bark was discovered by accident. It was used in traditional medicine, and at that time we didn't know anything about active ingredients. And with time, with laboratory techniques and observations, we were able to isolate salicylic acid from the willow bark. However, salicylic acid in pure state can also cause digestive issues. It can irritate the stomach lining, it can cause bleeding, and it can cause diarrhea. So we have then modified that active ingredient to create aspirin. So aspirin is more efficient and also less toxic than salicylic acid. And hence, aspirin is today used to treat pain and fever. So aspirin is a mild analgesic, which means that it is used as a painkiller. So it is widely used to treat pain and fever. We'll see other uses later on. Let's look at the synthesis of aspirin. So salicylic acid is going to be modified into acetyl salicylic acid. Acetyl salicylic acid, this is what we know as aspirin. And aspirin does not have the side effects of salicylic acid. So this is a molecule of aspirin, and it's made from salicylic acid and ethanoic anhydride over here. And an acid, sulfuric acid, concentrated sulfuric acid, or phosphoric acid is going to be used as a catalyst. So during the reaction, this part of the ethanoic anhydride will react with this functional group of the salicylic acid. So it's going to replace the hydrogen. So hydrogen is going to leave here, and this will fit in over here, will react with the oxygen here. So you end up with this group attached to the oxygen on the salicylic acid over here. And then this hydrogen will then bond to the rest of the molecule over here, and you end up with ethanoic acid. So it bonds here. Because the resulting product here, aspirin, is an ester, so you have the ester linkage here, COO, this is an ester linkage. So this is an esterification process. It's also called a condensation reaction, either or. Concentrated sulfuric acid is added to a reaction mixture. The mixture is warmed gently. The product is cooled to form crystals, which are then suction filtered and washed with cold water. We can then do suction filtration. So this is the setup for suction filtration. So this is called a Buchner funnel. And the Buchner funnel will basically just filter out any mixture over here and leave you with dry solid. So we have a suction which is created over here, and this will drive off all the liquid, all the solvent in that flask, in that Buchner flask. So over here you will have the soluble acids. So you will have the ethanoic acid, salicylic acid, sulfuric acid over here. And on top over here you will have the aspirin, the pure dry aspirin that is left here. Now you can watch the video which I have linked in the description box. It shows you the process of making aspirin in the lab. Now once you get the aspirin, you can determine its purity using melting point. Pure aspirin has a melting point between 128 and 140. If there are impurities in it, the melting point is going to be lowered, and it's also going to melt over a wider range of temperature. One way to find purity of aspirin is by using melting point, and another way is by using infrared spectrum. We're going to see that in topic 11.3. So infrared spectrum is just an absorption method which is used to identify chemical substances or functional groups.